passing by 2 degrees is a big dramatic
Mhm.
number in terms of heating. What do we know? Well, there are knowns and more uncertain impacts. What we do know with 100% certainty is that all extreme events will increase. So life-threatening heat waves. We know that the latest science shows that already at 2 degrees Celsius of warming, we would have somewhere between 2 and 2.5 billion people living in life-threatening regions in the world, just in terms of wet bulb temperature, that you would have average annual temperature levels exceeding 30 degrees Celsius, which would mean that either you're rich enough to buy air conditioners and hide yourselves in livable conditions, or you would be under life-threatening health conditions, which of course causes instability in societies, potential displacements, migration, and increasing levels of conflict.
Hi there and welcome to Swiss Impact with Banerjees.
Come along on this eye-opening journey as we dive into sustainability and impact investing.
Here you'll meet inspiring individuals who are crafting a brighter future for all generations to come.
The potential for impact investment is boundless, and you can be absolutely sure we are part of this positive change.
Are you ready to dive in and make a difference? Let's take action for the benefit of both mankind and nature. Welcome, dear audience, to the 12th episode of Season 8, where we will discuss climate change and sustainability. We will cover questions as when we crossing 1.5 degrees, what is the most immediate impact can we expect? What would be the consequences for our ecosystem if the Gulf Stream collapses? Doesn't matter if you're seated in the rich or poor country, we are all seated at the same boat planet. And so climate change is Ben's favorite topic. I guess I will not talk much today.
So today is a very, very important show as we will discuss the future of mankind in the present form as how we live today.
So can you elaborate more on that, please?
So, well, nowadays, when you talk to anyone here in Switzerland, they usually complain that this summer hasn't been nice this year. And the days have been cold and rainy.
Well, that is indeed true, with the temperatures jumping from 8 degrees in summer to 28 degrees next day.
Well,
Celsius, of course.
Exactly. Well, and cold and rain is the new luxury. Look at the places and countries like India, Middle East, and everywhere where the temperatures are reaching 50 degrees centigrade and people are dying of heat strokes. Add to that, only last year in 2023, nearly 3.6 billion people experienced water-stressed situations.
While the planet seemed to be reaching a boiling state.
And if our policymakers and elites, including financial institutions, do not understand or take this seriously, soon the planet will cross the livable threshold for people, for humanity, meaning 8+ billion people won't have place to live together and survive.
So today is needed a day of very serious and science-based discussion on what the world is facing and what can we do about it, which is very important to know. What can we do about it? So with this, I'd like to welcome our amazing guest of today, Mr. Johan Rockström. Hi, Johan.
Thanks. Great to be with you.
Great to have you with us on board, on the same boat planet. And for those who don't know yet, I would like to give not very brief, but a good introduction to what's your background. So, Johan, you are the director of the Potsdam Institute for Climate Impact Research and professor in Earth System Science at the University of Potsdam. As a consultant and advisor to various governments and international bodies, including the European Commission and the United Nations, you are an internationally recognized expert on global sustainability. You led the development of the Planetary Boundaries Framework and have over 25 years of experience in tropical water research with more than 150 publications. Additionally, you are also the chief scientist of Conservation International, chair of the Earth Commission, and chair the advisory board of the EAT Foundation. You also serve the European Commission's Mission Board for Climate Adaptation, and you are also a member of German Academy of Sciences Leopoldina. In 2024, you received the Tiller Prize for Environmental Achievement and named one of Times Magazine's 100 most influential people in 2023. I hope that was not too long, but
Yeah,
the world needs to
exactly.
know who is there they're listening to today.
And we met in Hong Kong, and we also met in one of the CLC board meetings, and also at the WEF.
Right. So, Johan, your career in climate science and sustainability spans over 25 years. What initially inspired you to pursue this field at all?
Yeah, well, to begin with, thanks, Sveta and Ben, to invite me. Great to be with you. And well, what inspired me? That's a good question. I started off in global hydrology and soil science. I got very early, already at my master's level at the Swedish Agriculture of University of Agricultural Sciences, um, inspired by a professor called Malin Falkemark. She's unfortunately not with us any longer, but she raised the whole global water crisis in the context of climate change and food security in the world. And that brought me to basically do my PhD in the most water scarce region in the world with regards to human security, namely in the Sahel region in Africa, and saw firsthand on the ground the challenges of building resilient livelihoods in the context of water scarcity, land degradation, and climate change for millions of rural poor across Africa. And so I was, from the very beginning, rooted in the challenges of local poor communities on the ground in connection to the global challenges of climate change and hydrology. So that's what brought me into the whole area of global sustainability.
Okay. And as the director of the Potsdam Institute for Climate Impact Research, and you are also the creator of the Planetary Boundaries Framework, what do you will consider your most significant contribution to global sustainability?
Well, to begin with, it's a community effort. I've been privileged to work with interdisciplinary Earth system scientists from climate research, oceans, stratospheric ozone, ecology, land, nutrients for many years. And what we find, and I would argue that's perhaps one of the most important contributions in science to humanity over the past decades, namely that 30 years, 40 years now of really extraordinary advancements in Earth system research shows with overwhelming evidence that we have entered a whole new geological epoch. We're in the Anthropocene. So we are, today, anthros is Greek for humans. We are the dominating force of change on planet Earth. We exceed the natural variability on planet Earth in terms of earthquakes and volcanic eruptions and solar radiation, natural variations that we as humans today exceed through our fossil fuel burning, land degradation, overfishing, air pollution. All forms of changes to the planet are today larger forces of change than the natural forces. And this was one big contribution scientifically that we brought together with the science on the risks of what happens if you allow this to continue. And we have seen tremendous advancements in science also over the last decades on understanding that our planet is a complex, self-regulating biogeophysical system characterized by interactions and feedbacks. And these interactions and feedbacks can, for a healthy system, go in a direction that helps us. So you have the ocean taking up carbon dioxide, you have the oceans taking up heat. 90% of the heat from our fossil fuel burning is actually not in the atmosphere causing the warming that you initiated the program with, all the heat we're seeing across the world. It's actually in the ocean. This is a stress response, but it's also an articulation of resilience of a healthy system that can dampen with stress caused by, in this case, our human induced forcing caused by fossil fuel burning. Another 25% of carbon dioxide is taken up by intact nature on land. A massive, I would even argue, the largest subsidy to the global economy that in total, 25% in the ocean, 25% on land of carbon dioxide is taken up from healthy ecosystems as a stress response, but also as a dampening factor to the pressures caused by human-induced global environmental change. Push that too far, we risk crossing tipping points, and we risk to irreversibly lose that capacity, and we can start drifting away from this healthy state towards a state that self-amplifies warming. And then the final strand of science that we've been able to integrate in the science that I've been privileged to lead on Planetary Boundaries is that we have so much ice core data, so much so-called paleoclimatic science, basically the science tracking the journey of planet Earth over the past 1 million years, showing that, we've been following a so-called limit cycle with 100,000 years of ice age, 15 to 30,000 years of warm interglacials, and we've been following that limit cycle over the past 1 million years. And that limit cycle has been regulated naturally through the planet Earth's orbit around the sun. So we understand this. It's so-called the Milankovitch cycling. It's mathematically well defined. But then we leave the last ice age 20,000 years ago, and we enter the last 12,000 years of warm interglacial, defined geologically as the Holocene. So this is the Holocene geological epoch. And it's when we enter this extraordinarily stable Holocene warm interglacial, the last 12,000 years, that we transition from being hunters and gatherers as us humans to domesticating animals and plants. We go through the Neolithic revolution, the agricultural revolution, where we become farmers, we become sedentary civilizations, and we start the journey toward the globalized world of today. And this is a piece of evidence that is so fundamental for our science on how to navigate our future, that we today can conclude that the Holocene, the past 12,000 years of stable, healthy, warm interglacial, is the very prerequisite for us to develop the civilizations, the world as we know it today. And now we are, as I started, deviating away from the Holocene because we're in the Anthropocene. We are today posing this global pressure on planet Earth. And put all this together, the Anthropocene with the pressures, the risk of crossing tipping points and shifting feedbacks and interactions from dampening and cooling to self-amplifying and warming, and the fact that the Holocene is our desired reference point for the planet. And all of this together took us to the planetary boundary framework, the breakthrough framework of defining a safe operating space for humanity on planet Earth. So there you have a scientific journey of 3 decades of remarkable advancements in our understanding of how we as humans depend on a healthy state of the planet, and why that took us to the planetary boundary science.
And you mentioned this term, the planetary boundary framework, a couple of times. Can you explain what it is and why is it crucial for understanding our current environmental challenges?
Yeah, so what I just described, Ben, is basically the background that took us to this point of the planetary boundary science. So what is the planetary boundary science? Well, it is a theory, a framework to guide humanity's future on planet Earth, and it tries to answer two questions. Question one is, now that we know that we're in the Anthropocene, now that we know that the Earth system is this fragile, self-regulating system, and that we have the Holocene as a reference point, question one that arises is the following. What are then the biophysical or the environmental processes and systems that regulates the state of the planet? And question two, can we, for each one of those, once we've identified those systems, which scientifically have been identified as 9 large systems. We can come back to what those 9 are. But the second question is, can we, for each one of these 9, identify a so-called control variable, a measuring unit that is a good parameter to measure the outcome, the state, the functioning, and the resilience of each of these 9? And can we scientifically quantify a boundary beyond which we risk to cause an undermining of life support, a drift away from desired conditions, but within which we have a high likelihood of remaining in a desired state for the planet, a state that is as close as possible to what we call a Holocene-like interglacial state that we know has a good chance to continue supporting the world, us as humans, as we know our world today. So there you have the planetary boundary framework. We have been researching this for the past 15 years, and we have identified 9 planetary boundary systems, and they are, not surprisingly, on this list of 9, you have the climate system, of course, a stable climate system, a stable ocean system, a protective ozone layer, the protective stratospheric ozone layer that protects us against dangerous levels of UV radiation. But you also have 4 planetary boundaries, which I call the biosphere boundaries or the nature boundaries, that do not have any evidence of planetary scale tipping points, but they work under the hood of the Earth system to keep the health of the planet intact. And these are the following: biodiversity. So we call this biosphere integrity. The the health of the natural systems on planet Earth, both in the ocean and on land. The second is what we call land system change. So the configuration of big forest systems. We've understood now scientifically that the tropical forest, the temperate forest, and the boreal forest are determining factors for the functioning of the whole Earth system. The third is, of course, what I call the bloodstream of the whole planet, the hydrological cycle, the freshwater system. Without fresh water, no life. Without fresh water, no biomass. Without fresh water, no biodiversity. Without fresh water, no carbon sequestration. So the bloodstream of the planet is really to keep the hydrological cycle within a healthy range of functioning. And finally, the climate system is regulated to a very significant extent by one big cycle, the carbon cycle, the carbon dioxide cycle. But there are 2 sister cycles, the 2 biogeochemical cycles of nitrogen and phosphorus. Think of them as the nutrient cycles, the cycles of nitrogen and phosphorus, which determine the level of eutrophication of oxygen levels in marine systems. These are largely impacted by us through fertilizers, phosphorus fertilizers and nitrogen fertilizers. So those are the nature boundaries: biodiversity, land, water, and nutrients. And then you have finally 2 boundaries, which you could think of as a bit sloppily, perhaps, but you could think of them as the aliens. They are the boundaries that do not exist naturally on planet Earth. They've been created by us humans. Number 1 is what we call novel entities, which is chemicals, persistent organic pollutants, nuclear waste, microplastics, PFAS, antibiotic overloading, everything that is chemically loaded in the Earth system artificially by us humans. And secondly, aerosol loading, which is air pollutants, which is the evidence that we are causing so much air pollution in the lower atmosphere that it can change the whole energy balance on the planet and the whole monsoon system, for example, in Southeast Asia. So there you have the 9, 3 big ones: ocean, stratospheric ozone layer, and climate. 3 natural biosphere ones: biodiversity, land, water, and nutrients. And 2 human created: aerosol loading, air pollutants, and chemical pollution. The latest assessment from 2023 shows that 6 of these 9 are outside of the safe operating space. So it just proves that we are putting the stability, the resilience, and the life support systems on Earth at risk. We are really in a very challenging situation with regards to the entire planet and its role in supporting human well-being, equity, and prosperity for humanity.
Thank you for explaining that in such detail, Johan. I think it's everyone learned a lot. Next question about the famous 1.5 degrees threshold. So what it is, I'd like to hear it from a source, and what immediate impacts can we expect if the world surpasses this threshold within the next 5 years?
I think we have already, Johan, correct me if I'm wrong, but we have already passed it the last 2 years.
Well, you know what? Let me try to explain this to yes, Sveta. I think this is a really important question, and I appreciate particularly because so the climate planetary boundary is set actually slightly below 1.5 degrees Celsius, and that is for precautionary reasons. But I can tell you that we use our tipping point science as one of the sources of evidence to set the safe boundaries. And we today have significant scientific evidence showing that if we pass 1.5 degrees of global mean surface temperature rise, so the pre-industrial average temperature on Earth is 14 degrees Celsius on average, and adding 1.5 scientifically leads to the likely crossing of tipping points of the Greenland ice sheet, the West Antarctic ice sheet, abrupt thawing of permafrost, losing all tropical coral reef systems on planet Earth, and collapse of the Barents Sea ice. And these are 5 so-called tipping point systems on planet Earth. All of them contribute to regulate the stability of the climate system. And just those 2 ice sheets, the Greenland ice sheet and the West Antarctic ice sheet, hold 10 meters sea level rise. Not that it would, be a tsunami overnight, but if we would cross the tipping point, it would lead to irreversible melting. So we would be handing over to all future generations, even if it would take 1,000 years to melt, an unstoppable melting. So there you have, in a nutshell, one of the most important methods we use to set the safe boundaries. 1.5 degrees Celsius is set as a boundary to keep us away from crossing tipping points. Once you cross those tipping points, you have a weaker planet that simply moves in the wrong direction. So therefore, I today basically conclude the following: that 1.5 degrees Celsius, that is in the Paris Climate Agreement, that every country in the world has agreed to aim to hold, is not, as often portrayed in politics, a target or a goal. It's a limit. It's a boundary. It's a boundary beyond which you take big risks. You don't want to go there because we would risk undermining the livelihoods for humanity. So that's why 1.5 is so important. And your question then, Ben, haven't we already reached 1.5? Well, in scientific terms, the answer is no, because of the following. So if you look at the temperature curve, you are absolutely right, Ben, that in 2023, on average, the calendar year 2023 reached 1.45, 1.48. So we basically just touched 1.5. If you look at the monthly values, we've actually had 12 months now beyond 1.5. We're actually having a 12-month period that according to certain observations actually reach above 1.5. But scientifically, when you look at how we define global mean surface temperature, we actually take a 20-year moving average. So you look at the average temperature 10 years back and try to predict as best as we can the expected temperature in the coming 10 years. And that 20-year moving average has reached 1.2 degrees Celsius today. And that is the number that is actually, let's say, the one that is
Mm-hmm.
equivalent to what the Paris Agreement is aiming for. Then the question, of course, is when are we likely to to crash through that global mean surface temperature rise,
Right.
the 20-year moving average? And the best assessment we have today is that we will do that somewhere very soon, unfortunately, already between 2030 and 2035. So basically, within 5 years, 6 years earliest, and somewhere within 10 years. And this is a very, very worrying trajectory, because once we pass 1.5, and what that means is that we would be permanently outside of 1.5, then we
Mm-hmm.
take big risks with regards to these tipping elements I just mentioned. Does that mean that we have, so to say, lost the chance of holding 1.5? The answer is no. I mean, it is a scientific debate, but my conclusion is, and many scientists with me agree, that the answer is no. We can still hold 1.5, but we can only reach 1.5 after what is called overshoot, meaning that we have loaded so much greenhouse gases in the atmosphere. There's so much heat already in the pipeline that it is impossible to avoid crashing through 1.5 within the next 10 years or so. But we can still, according to the climate models we have today, hold 1.5 after a period of overshoot, and reach 1.5 by the end of this century. What does overshoot mean? Well, it's not it's it's quite a gloomy period, because at best, what we know today, it would entail a 30-40 year period of zero point 0.1 to up to 0.3 degrees Celsius above 1.5. So we are very likely facing a generation, I mean 30 years, of being up to 1.8 degrees Celsius before we may come back to
Mm-hmm.
1.5. This means that there will be more droughts, floods, fires, heat waves. I mean, that would, we can say that with 100% certainty, unfortunately. So it will be, we will go into a rough period. It will get worse before it gets better. And why would it get better finally? Well, it can only get better if we start phasing out fossil fuels, if we start phasing out emissions. So the only reason why the planet would come back to 1.5 is that two criteria gets fulfilled. One is that we deliver on what we promised in the Paris Agreement to reach a net zero world economy by 2050. So we stop loading more carbon dioxide and other greenhouse gases. And secondly, that we come back into the safe space of planetary boundaries. So the planet, meaning nature on land and nature in the ocean, can continue to help us in taking up carbon dioxide, so that we can, get a cooling back to 1.5. Because now we are in what we in science called in an imbalance. We've caused turbulence in the whole system. We are in energy terms in an unbalanced position, and the planet will search for a new balance, and the balance will be determined by the ocean, by the ice sheets, by the forest systems, by the soils, by the wetlands, by the permafrost. And if we keep these systems intact, we have a higher chance that these systems in the process, in the journey towards a new equilibrium, is able to help us dampen. But if we destroy these systems, you can just imagine, then the risk is that we actually don't come back to 1.5. Then we might drift towards warmer and warmer conditions instead. And that, of course, would be you know.
Disastrous. Yeah.
Exactly, exactly.
And
It would actually be disastrous.
and
And can you name the disaster? So imagine 20 years, we are just going this direction. We don't change.
Mm.
How will climate, water, food, biodiversity be affected? What is the kind of worst case
Yeah,
scenario, or like scenario if we don't change? It's just like, many people don't change. I've been
yeah.
yesterday at some financial event, and bankers are still bankers. They talking about election in US, impact investing, climate is not on their
Mm.
agendas,
Yeah,
so.
so if we don't change, I mean, to begin with, if we don't change, we would, according to the Intergovernmental Panel on Climate Change scenarios, we would pass 2 degrees Celsius somewhere, around 2050. So that's not far away, 25 years from now. And we would reach almost 3 degrees Celsius of warming outside of the pre-industrial 14 degrees Celsius by the end of this century. So in 75 years' time. And I can tell you that 2 degrees Celsius, just crashing through 2 degrees Celsius, would be the warmest temperature on Earth for the past 3 million years. And if we reach 3 degrees Celsius, we would be in the warmest temperature on Earth, as far as we know, over the past 4 to 5 million years. So we're talking massive changes. And remember, we've only existed as modern humans on planet Earth for the past 250,000 years. And it's only in the past 12,000 years that we've developed, civilizations as we know it. Before that, we were, just a few million people living in caves as hunters and gatherers. So,
And
so
maybe
we're,
they
we're
were more
talking,
happy, Johan.
yeah,
Maybe they were more happy.
yeah, yeah. Don't that they may have been more happy. They lived through ice ages, and but I would argue that they had a rough time. And it was only when we came into the Holocene and had very harmonious conditions on Earth that we could
Mhm.
domesticate animals and plants. But so to start answering your question, Sveta, passing by 2 degrees is a big dramatic
Mhm.
number in terms of heating. What do we know? Well, there are knowns and more uncertain impacts. What we do know with 100% certainty is that all extreme events will increase. So life-threatening heat waves. We know that the latest science shows that already at 2 degrees Celsius of warming, we would have somewhere between 2 and 2.5 billion people living in life-threatening regions in the world, just in terms of wet bulb temperature, that you would have average annual temperature levels exceeding 30 degrees Celsius, which would mean that either you're rich enough to buy air conditioners and hide yourselves in livable conditions, or you would be under life-threatening health conditions, which of course causes instability in societies, potential displacements, migration, and increasing levels of conflict. The second thing we know this means is that the heat leads to more evaporation, which leads to drying out of landscapes, which leads to more fire. So exactly what we're seeing in Greece right now is what you will see essentially across the entire Mediterranean area, in Southwest US, in Australia, in all arid, semi-arid regions in the world will have much higher frequency of this trend: heat, evaporation, drying, fire, devastation. So that will increase. We will lose all the tropical coral reef systems on Earth. These are livelihoods for several hundred million people across the world. We will very likely, we will with certainty have more extreme rainfall events, because what happens is when temperatures rise, you get more evaporation also from the ocean. That leads to powering up the hydrological cycle. You get more vapor in the atmosphere, and you get more extreme downpours of water. So you get more floods, and paradoxically, so you get more fresh water, but it's not good because it doesn't fall down gently. It falls down as extreme downpours,
Mhm.
which we are experiencing also in the temperate region already today, in regions like in Germany and the floods 2 years ago. So that we know that this is we know for certain: warmer temperature, more extremes. What don't we know? Well, what we don't know is what happens with pandemics, what happens with tick-borne diseases and dengue and different tropical diseases moving north. What happens with ice sheets? We are very likely losing all the inland glaciers. What happens with the third pole, the Himalayas, which is the freshwater tap supply system for the big rivers like Ganges, and supply of
Brahmaputra.
fresh water to
Yeah.
huge parts of Asian populations. What happens with the tipping point systems? Will the permafrost cope with this? Will the Amazon rainforest cope with this? We simply, in all honesty, don't know. Are we at risk of causing massive changes in the ocean stability? So we have knowns and unknowns, but all science shows clearly that we should stay away from crossing
Mhm.
those dangerous levels of temperature rise.
I'm asking myself, why did I ask this question?
Yeah, well, it's you have to blame yourself.
I tend to direct my mind to positive, so we driving that direction. But it's good to know. Thank you. So next question is yours,
Yeah.
Ben.
So you mentioned the ocean, and recently in the news it has been coming a lot about the impact of global warming on the Gulf Stream and the Atlantic Meridional Overturning Circulation, the AMOC. So what recent findings in this area for you are most concerning?
Yeah, so we have been researching this for decades here at the Potsdam Institute for Climate Impact Research on the AMOC, the Atlantic Meridional Overturning Circulation, the circulation of heat in the North Atlantic. And remember that the ocean system on planet Earth is a connected ocean conveyor belt of heat, of
Yeah.
energy. And it's driven through thermodynamic engines, and these thermodynamic engines are quite straightforward. Actually, it's so-called thermohaline engines. So what happens is that the Southern Ocean flows on the surface salt, warm water up on the surface, reaches the Gulf of the US and the East Coast, and then reaches the southern tip of Greenland. And there it releases heat to the atmosphere, completely natural, makes it possible to live in where I come from, in the Nordic region. And then salt water is heavy, it has high density, so it sinks. And when this sinks, it is the very engine that pushes the water back on the bottom of the ocean down back to the Southern Ocean. And this is what keeps the circulation going. We have three of these thermohaline engine points, as far as we know, and the AMOC is one of them. Now, what's happening is that when the Greenland ice sheet is melting very fast, it releases cold fresh water into that southern tip, that the engine point for the AMOC. That dilutes the heavy saline surface water. So it's not heavy and it gets lighter, so it sinks slower. And when it sinks slower, it slows down the whole overturning engine, which then makes the AMOC slow down. And observations indicate that it's slowed down by 15% so far. And this is what we're worried about. Is there a risk that the AMOC collapses, that it shuts down? And one part of the AMOC is the Gulf Stream. The Gulf Stream is a kind of a one part that stretches up towards the North Sea. But let's talk about the AMOC. And I can tell you that there's a big scientific, it's a wide scientific debate about this. There are research groups that show that there is a risk of a shutdown of the AMOC within this century. I mean, already before 2 degrees Celsius global mean surface temperature rise. And there are other groups saying that the risk is very limited. We here at the Potsdam Institute have been doing some of the most advanced research on this, led by a professor called Stefan Ramstorff, but also researchers like Levke Cesar, showing in recent publications that we cannot rule out a collapse of the AMOC even within the coming century. Two recent papers came out just over the past few months, supporting this conclusion with really big climate modeling runs that you cannot exclude that happening, but nobody has been able to set the exact temperature for a tipping point. We have recently published the best estimate of temperature range risks for the AMOC and placed this higher up than 2 degrees Celsius. So we still don't have full support of knowing exactly when this may happen. But the risk is there. Has it shut down in the past? Yes, it has shut down many times over the past 1 million years, but then also restarted again. So it really is a system that can flip back and forth. What happens if it collapses? Well, I can tell you that is quite well established, that it would lead to dramatic cooling of regional temperatures in Russia and Canada and the Nordic region. It would lead to rapid increased rate in sea level rise. It would very likely shut down the monsoon system over South America. So it would be very dramatic impact on droughts and fires in the Amazon. And it would have impacts all the way down to Antarctica because the conveyor belt is interconnected. So it would have global impacts. It's one of these systems that reside in the North Atlantic, but it is connected to the entire global system. So we don't want that to happen. And so coming back to your point, Sveta, that this kind of information makes you, let's say, almost regret that you asked the question. Well, I would kind of challenge that and say, isn't it fantastic? Isn't it fantastic that we know this, that we have at least enough knowledge scientifically to say you don't want to go there, because it's still up to us to avoid this happening, and we can avoid it. And isn't it fantastic that we actually have these boundaries, these kind of limits, that you don't want to take the risk. I mean, even if there's an uncertainty range, why risk collapsing the AMOC? I mean, of course we want to avoid that, and we know that, well, that gives us even more support for 1.5 degrees Celsius.
Yeah. No, I absolutely love that. You know, I ask you a question, you provide the answer. You also answer questions which are coming on our mind, and you provide the solution. It's just now in our hands to act, right? So that's why we are doing it today. Mm-hmm.
And even countries like Switzerland, which is historically very climate resilient, at least we don't notice that so much here. We are facing now severe impacts like receding glaciers, devastating floods. And what does this indicate about the global climate resilience? And what lessons should we be learning from these events? I mean, even in India now, the temperature has gone 50 plus. And what worries me is that you have 1.4 billion people. If the agriculture system or the production there is impacted, you have 1.4 billion people to feed. So what are the impacts of this?
Yeah, well, to begin with, Ben, I think it's important to remind ourselves that we in Europe, or we in the richer part of the world, are not protected against climate change. We're all in the same boat. We're all impacted. And actually, when you look at Europe, and particularly a country like Switzerland in the northern parts of Europe, is warming on average twice as fast as the global average. So Switzerland is already at 2 degrees, and that's why you're seeing melting of your glaciers even faster than we had expected. So even the temperate north is impacted. I mean, the only reason why we tend to be more concerned about India and the Sahel and many of the tropical regions is for two reasons. One is that you have a predominance of the poor, more vulnerable people living there still. But secondly, these are regions that are inherently more environmentally vulnerable. You have a higher degree of natural water scarcity and natural high temperatures from the very starting point. So of course, when a very precarious environment becomes even more precarious, then you're hit harder than if you are in the mountainous area in Switzerland, where you start from a very harmonious starting point. So that's the only reason. But change is happening as fast in Switzerland as it is in India. It's just that you don't reach 52 degrees Celsius
Yeah.
in Switzerland as you did in Riyadh and in Mecca during the pilgrimage
Yeah.
of Hajj this year, because you are already in a desert region and it goes from warm to disastrously warm. Um, so so we are, if there's any message from science at this point, and I know that this is it's one more of these, Sveta, uncomfortable statements.
I'm open to everything,
Okay,
you
yeah,
know.
you're ready now. You've seen
I'm very
one.
resilient and resistant. Don't worry. That's why
Yeah.
I can
So
digest. I'm not gonna cry this time.
yeah,
Sometimes
so
I do cry on our TV
I'm
show.
hitting you.
But
I'm hitting you full blast. So if there's any red thread in science over the past 30 years, it is this: we've underestimated the pace of change. Things are
Mhm.
actually changing faster than we had expected, and this is worrying us. I mean, we are observing right now faster melting of inland glaciers, faster rise of temperatures, shockingly faster rise of sea surface temperatures in the ocean, to the extent that we cannot actually even explain it fully. So, so yes, Ben, there is what we are the fact that we have started to observe over 40 degrees Celsius essentially on all continents happening quite frequently
Mm.
is something that exceeds what we had expected already at 1.2 degrees Celsius of average temperature rise.
And so, do you believe that climate change could be as damaging as, I don't know, 50, 100 times worse than COVID pandemic?
The answer is well, I wouldn't set a number like that perhaps, but that it would be equal
Of course,
to.
you're the scientist. You cannot do that.
But if it let me give you some numbers. So um, we know today that millions of people are affected already today of climate extremes, and during the pandemic we had millions of people being affected by COVID. And if you look at just one statistic, is that on average, some 8-9 people die prematurely each year just of air pollution caused to a large extent by greenhouse gas emissions from fossil fuel burning. That number is the same magnitude of people who lost their lives prematurely because of COVID. So
Mhm.
so the pandemic was a global crisis, but its magnitude of impact is in the same order of magnitude of people affected by the negative side effects of what's causing climate change, and also by the impacts of climate change. Not in terms of deaths when it comes to impacts, but impacted people in terms of displacement and water scarcity and food insecurity. So yes, I mean, I would say that we need to understand that we are facing a planetary scale challenge, just like we had a planetary scale challenge during COVID.
Yeah.
Yeah. I have more questions. I know we're a bit over
Yeah,
time,
no, no, I'm
but
just thinking maybe we should have two times because we have so many questions for you, Johan. So, Johan, we will have to invite you again back for a second time to continue because we have so many questions which you have covered today and so many more. But go ahead.
so my question was very practical. So, in your view, where are we failing short in tackling climate change? Is
Mm,
it technological inefficiency, lack of political will, our stupidity, human greed, short sightedness? What is that?
mm. Well, to begin with, I'm happy to come back, and if we have this as a final question, let me just really emphasize that, and to answer your question, Sveta, at least
Mhm.
attempt in part to answer it, is that, you know, we are today facing a double frustration in the scientific community. So frustration number one is what we've been focusing on, which is all the evidence that we're facing, you know, potentially unmanageable, but certainly unacceptable risks. But the second frustration is that we have so much evidence today that we actually have the scalable solutions, that we can solve this climate crisis. We can power at large scale economies, nations, industries with green energy systems, even without subsidies today. Did you know that on any market in the world, renewable energy outcompetes coal-based electricity, even without
Mm-hmm.
subsidies anywhere? It's it's quite remarkable how we are today at double-digit percentage points on scaling solar and wind. We're no longer at a pilot phase anywhere. Electric mobility is simply outcompeting the internal combustion engine. And we know that there are two big transformations that can take us back within a safe operating space of planetary boundaries. And number one is uh, the energy transition, of course, phasing out coal, oil, and gas. But the second one is the food system transformation. If all people in the world start eating healthy food, more plant based diets from sustainable food systems, we really veer back into the safe operating space very quickly. And the question is this possible? Do we have those solutions? And the answer is yes. We know how to produce sustainable food without destroying ecosystems. We know how to be able to do it increasingly without using fossil fuels. So the question is, why aren't we doing this? Why aren't we, rapidly
Exactly.
transitioning? And I would say that there are two big entry points why we're not doing it. I mean, number one is the the deep grounded vested interests in our global economy resisting change that we're simply are so inbuilt into our standard GDP based growth model, the linear business models that exploit in one part and causes waste downstream without paying for any of the natural capital used. And you have big players that wants to, you know, either even be skeptical and deny. They are very few actually, but there are very large vested interests that let's say on short term at least gain on not changing away from the current industrial logic in the global economy. And the second reason why we have a challenge here is that as compared to the pandemic, what we're facing is an equally serious challenge, but it's a slow challenge. It's not
Mhm.
it's not something that hits you in the head Monday morning. It is basically to hand over a planet in a healthy state for our children, and it's a long term factor, and nobody gains just you cannot talk about a profit making efficiency for over the next year. It's about building in a welfare strategy over a generation, and this is
Mhm.
difficult. One has to recognize that we don't have the economic or the institutional or the politics really to handle those long term trajectories, and we need to. That's what we're struggling with every day, basically, to how to build in institutions and governance and politics and economic incentives to be able to correct the market failures. And the failures are the fact that we are allowing ourselves to just generate short-term benefits at the expense of future impacts. I mean, strictly speaking, everything that we are doing wrong today is that we are living at the expense of future generations, and actually increasingly even current generations because of the impacts
Yeah.
that are hitting people today. So my point is that uh, we have the solutions. We have to never give up. Always hold on to 1.5, even if we're facing overshoot, and really communicate the fact that the solutions give us better prosperity and better equity, and this is not a journey of sacrifice. And that, I think, is a way of unleashing this inability of vested interest to
Mhm.
dominate still the discourse today in the world.
I would like to add two facts which I recently read. One is that the sale of air conditioners in India has nearly doubled, and these
Yeah,
air
yeah,
conditioners are running on electricity which is being produced by coal power stations, which is
yeah.
exactly counterproductive. And the second thing was that BP recently, it was on the news, the British Petroleum, that they are moving out of green energy and back into fossil fuel because of the shareholders.
Yeah, but there you see that the short-sighted vested interest, and what you describe with air conditioning, Ben, is what we call rebound effects, and this is really something that worries us. That you see we burn fossil fuels and cause heating and climate change, and then the response to that is to buy more air conditioning, which just reinforces global warming even more.
Yeah.
So it's a vicious cycle, and we see that in so many of the so-called climate adaptation measures, and we need to break that bad cycle.
So very, very last question for today. I hope we can convince you to come second time because there are more questions and answers. But could you please share your call to action message to any viewer? What can normal people, anyone do already today?
To talk to your friends and try to keep your ears on the ground on where science is, and particularly help us in what science says, namely that we have a whole new narrative, a whole new discourse where sustainability and solving the planetary challenges is a path to success, the winning path towards modernity, towards attractive, healthier, secure, better economies, stronger societies, is a path following a sustainability journey. Moving towards the path where we are today is a dead end. And I think that's the most important thing that anyone can do. Second is, of course, to be part of this change process and take choices on, diets and transport and consumer goods and everything we do, and not see this as a sacrifice. This is an exciting journey towards a better life.
I love that. Thank you so much,
much.
Johan. It's I always say you want to see the change in the world, change yourself, right? If we cannot
Yes.
even change ourselves, what do we want to change outside there? Thank you for joining us today. Thank you for your sharings and scientific knowledge. Really appreciate it.
Thanks for inviting me.
Thank you. Bye. Bye for now.
So with this, dear audience, I hope you are not depressed, but inspired to do something about your life, which is very valuable. Remember, human life is very valuable. So do something about it. And also, as Johan said, it's not only for future generations, it's for current and future generations. Bye
Bye
for
for
now.
now. Thanks for joining us on this fascinating journey today.
We hope this incredible story has ignited something in you. Don't miss out on what's coming next. Subscribe to our channel and stay tuned.
Feeling inspired to support our guests or be featured on our next show? Get in touch with us at apply@iisolutions.ch.
Let's stay connected. Find us on TikTok, LinkedIn, YouTube, Facebook, Spotify, or any other social media platform you love.
We are super excited to share our upcoming episodes with you.
See you soon.